In this video, I will present free body diagrams. Free body diagrams can also be called force diagrams. So what is shown on a free body diagram are forces. There is no velocity on a free body diagram, there's no position, it's only forces. So a free body diagram shows all forces acting on an object or sometimes on a system of objects. What you need to do is sketch and label all of the forces. So in this situation, so this is a book being held by hand. So a book being held by a hand. The net force on this book right now is actually 0. I know that because the book's not accelerating. It's not moving at all. So it has no velocity, it has no acceleration. Since there's no 0 acceleration, this tells us, since there's no acceleration, that means the net force has to be 0. But there's still a free body diagram that you can draw for this book that has arrows in it. The arrows represent the forces because there are 2 competing forces going on to hold this book in the air. One of those forces is a normal force. So that was the force from my hand pushing up on the book. If I had removed my hand, the book would have fallen. And that's because of gravity, the other force. So these represent the forces acting on the book. They're not acting on the book and the hand. If I included as my system both the book and the hand, now we have to think about my arm, my shoulder. Where's the force coming that's keeping my hand where it's at? Okay? So be sure you're very clear when you make a free body diagram. What I'm interested in right now is the book, not the hand. I'm not going to draw forces that are acting on the hand. I'm only drawing forces that act on the book. So the book has a normal force up from the hand and a gravitational force down from gravity. So you can draw a free body diagram as the object itself with arrows representing the forces, labels on the arrows, or the simpler way to do it is to say, okay, this dot represents the book. Then, with the dot representing the book, there's a normal force up and there's a gravitational force down. If you know something about the magnitude of these forces, you should also try to make the arrows proportional to the magnitude of the force. In this case, we knew the net force is 0, so whatever force is acting up, there has to be an equal and opposite force acting down. So both of these arrows have the same length, the same magnitude, showing that these forces also have the same magnitude. When we hit chapter 10, things will start rotating. So if I've got a force acting up here and down here, then I'm concerned with how the object's going to rotate. Until chapter 10, we're not going to have things rotate, so we will show all forces acting on a point at the center of the object.